This is the lab called Heating and Cooling Water A. Heating and Cooling Water A. It's on page 34, and it's pasted into your spiral. And in this lab, we are following the procedure right here. And we'll walk through this and have a little discussion on it so that you can get the science between what exactly happens when we heat a volume of water and then cool a volume of water. So this is a shortened version of the lab that you did in class, and I'm showing it again so you can revisit one more time. Okay, this is a video to review what we did yesterday in our lab called Heating and Cooling Water A. And then today we will take some time to go through the questions in Heating and Cooling Water B. So I've got all the items that we need, just like you had when you did the lab, and here's the procedure. And I'm going to walk through it one more time. So these are all the items we need. First thing was we need to set up a bottle system like the one we have here. And the first step would be to get 35 milliliters of room temperature water. And I've dyed it blue so that you can see it. And we put it into the small glass jar. Alright, so there's my 35 milliliters. The next step was to take the plastic tube that's been put into the one-hole stopper and place it into the jar. Squeeze it down tight. You can see it rising. And then we have a pipette, and we're going to pull out some of the water so that it's about halfway down. Let's put it in there. Maybe take a little more out. And that looks good. Okay, so in this activity we are going to be placing this bottle into cold water for 3 minutes. I've got some cold water here. I'm going to dump it in, fill it up to the line. And like all good scientists do, we'll do some observing. So we've got the water up to the line. We're just going to place the bottle system. Oh, I almost forgot to mark. We need to mark room temperature, or the level at which the water's at. Put a little R there. Alright, just like you did. Place it in. And observe for 3 minutes. And we are on the clock. So this is where we're going to go to the land of make-believe. And in the land of make-believe, we can make time go by faster. Time can go by faster. So I've got my little stopper here, and we're at about 25 seconds. And for the sake of this video length, we're going to go 3 minutes has gone by, and like all good scientists do, they observe. And we can see that the line of the water, now has dropped below the R. So I'm going to label that C because it's in cold water. Wonderful. So the water has dropped in the plastic tube. And the next part of the experiment was take warm water, fill it up to the line, and place the bottle system in the warm water and observe. And slowly but surely, we see some changes occurring. And you can actually see that the water level is starting to get higher. So it went starting at room temperature, put it in cold water for 3 minutes, it dropped to a new level. Now we've got it in the hot water, and we can see it's risen quite a bit above the room temperature, and we're going to go back to the land of make-believe. Time warp. We're going to pretend that 5 minutes has gone by. 5 minutes has gone by, and because my water is pretty hot, water is pretty hot, 5 minutes, we'll mark it, and we'll write H for hot, and we see that it has risen up to that point, H for hot. And I can prove that to you. I can prove that the land of make-believe is actually the land of reality. And after 5 minutes, yes, we can see that the water level has reached the top. I did forget to take the temperature of the cold water with the metal thermometer. And if I put that in, you can see this is an alcohol thermometer, and it starts to drop. And I believe it's about 5 degrees Celsius, 5 degrees Celsius. So it's interesting that alcohol is a liquid, and it dropped just like it dropped when we put it in, when we put the bottle system into the cold water. It's kind of interesting. I'm going to put it back in the cold water. And now our hot water, you can see it raising up. Leave it in there for a few more seconds. I think most people had it at about 65 in class. This looks like about 60. Okay, so that was the lab we did. And now you have to think about not just what happened, because you observed what happened, but why does it happen? Why does it happen? And we'll be comparing why this happens with a liquid to our previous lab when we used water bottles that were empty, where we compared what happens to a volume of air when it's heated and what happens to a volume of air when it's cooled. Okay, so that is a short synopsis of the video that you did in class. And obviously we were in the land of make-believe a little bit there. But it's good to see it again, to revisit when it's heated. And the liquid will fall when it's cooled, rise in the plastic tube or fall in the plastic tube. So with your group, your partners, you need to go through and answer the questions excuse me, that go along with the activity. Okay, you need to answer the questions. So the main thing I'm going to tell you is to keep in mind that this was the picture, and I'm going to put 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 particles. This was, we're going to call this room temperature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles. We're going to call, we'll call this the heated, but I want you to remember that when it's heated, kinetic energy, the kinetic energy of the particles increases. It goes up. That means they move faster. These particles here are slamming around, bam, 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 into each other. Okay, and that is what's happening with the liquid, the particles of a liquid. And a liquid is a phase of matter. I'm wondering, isn't this the same thing that happened with air when we heated it? So if we were to draw what's happening with these particles, the size of the particles is definitely not increasing, but they are really slamming in this case, to the glass jar, the sides of the glass jar. And there was only one way out, and that was through the plastic tube that we had stuck in the stopper. So the liquid, as you saw it with the blue dye, started to go up when it was heated. Now on the other end of the spectrum, if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles that are put in cold water, the size of the particles does not shrink, but just the opposite of the hot water side, just the opposite. In the cold water, the kinetic energy of the particles, I'm just going to write kinetic energy decrease. That means the motion of the particles slows down considerably. So those particles, we could say, huddle together, or the correct term would be contract. And since we only had the little plastic tube to view the results of what happens when the liquid is in the cold water, we saw that the blue started here at room temperature and then it fell down. So maybe it was here for the cold water. Particles didn't disappear. The kinetic energy, the motion of the particles slowed down, and we call that contraction. So contract in the cold, and if you remember from volume of air in hot, we don't call that contract. When in this case they rose up the tube, we call this expand. The particles expand because they have more motion, they have more kinetic energy. And that is the science that you need to remember. So go through the problems. There's 1, 2, 3, 4, 5 of them. Make sure you're writing in complete sentences. If it says explain, explain. Use good punctuation. And do your best work.